Welcome to the 35th lecture of Digital Electronics. In this lecture, we will be dealing with how to realize a Boolean expression using AND logic, OR logic, using AND or inward logic, NAND logic, as well as NOR logic. So here in AND or inward logic, in AOI logic, you are allowed to use only AND gate, OR gate, and NOT gate. Whereas in NAND logic, you are allowed to use only NAND gate. In NOR logic, you are allowed to use only NOR gate. Okay. So that is the basic principle which we need to follow. Now, let me start with an example. Okay. So, first question: realize using AOI logic, NAND logic, and NOR logic. The question is f is equal to AB or CD. Okay. So coming to AOI logic. Okay. Here what is the first term? Here first term is AB. So we can go for AND gate. A, B. So AND gate is ready. Second term is CD. Again we can go for AND gate. C, D. That is another AND gate. That two are odd. So here what do we get? This is AB, this is CD. So you will get here AB or CD. That is equal to F. Okay. So your AND or inward logic is ready. Next one is I am going to deal with NAND logic. How to deal with NAND logic? Okay. So the steps to form the NAND logic is first step, convert AND to NAND. Second step, convert OR to bubbled OR. Third one, attach NOT gate to preceding bubbles. Okay, attach NOT gate, by preceding, not to by preceding. By preceding bubbles. By preceding bubbles if necessary. Okay. So these three are the steps which needs to be followed. Okay. So here I am having NAND gate, here AND gate, here also I am having AND gate. So first I am converting it into a NAND gate. So we get A, B. So this is AB bar. So again here what we have C, D. This is CD bar. Now coming into this one. Now coming into next part. I am replacing this OR by bubbled OR. Yeah. Okay. Now let me check the operation of this bubbled OR. Okay. So for this bubbled OR, what I am having input? I am having input as say X bubbled and Y which is bubbled. So here what will you get? You will get H bar or Y bar. Yeah. Okay. So what is H bar or Y bar? That is same as HY bar. That is according to De Morgan's law. Okay. That means this bubbled OR gate can be realized as a NAND gate. bubbled OR gate can be realized as a NAND gate. Now here you can see AB bar is coming in and CD bar is coming in. Okay. Now if it is bubbled OR gate, here what we get? AB bar or CD bar. Okay. What is it? So what we get is AB or CD. This we can write it as AB bar dot CD bar the whole bar. AB bar dot CD bar whole bar is AB or CD. Therefore we can directly convert this bubbled OR gate into NAND gate. So you get AB, A, B, C, D, and you will get a NAND gate. Okay. So here what we get? This is AB bar, this is CD bar, this is AB bar dot CD bar the whole bar. So what is it? That is AB bar or CD bar. What is it? That is AB or CD. Okay. Now I have realized this AND or inward logic using NAND gates only. Now coming into NOR logic. Okay. So here the three steps which is to be followed are: first step is convert OR to NOR. Second step, convert AND to bubbled AND. Convert AND to bubbled AND. Convert AND to bubbled AND. Then convert AND to bubbled AND. Third step, insert NOT gate preceding bubbles if required. Okay. So our question is F is equal to AB or CD. So first I will go with AND or inward logic. Then I will go. Then after that I will go with NOR logic. So we are having A, B as input. So you get AB. Next one is C, D as input. This is CD. Then AB or CD. That is F. This is equal to here what we have is AB or CD. Now coming into NOR logic. Okay. First step is convert AND to bubbled AND. Okay. So convert AND to bubbled AND. So we have A, B. This is bubbled AND. Okay. C, D. So this is bubbled AND. Okay. So here what we get? Here we will get A bar dot B bar. This is C bar dot D bar. Okay. Now convert OR to NOR. I'm just converting OR to NOR. Now if you are checking the result, here what do we get? A bar dot B bar or C bar dot D bar the whole bar. Okay. So what is it? What is it basically? This is basically A bar dot B bar the whole bar dot C bar dot D bar the whole bar. So what is it? That is, you can take it as A or B and C or D. That is A or B and C or D. Okay. So so here what you have got is here what you have got is the POS the dual form. The dual form of F. Okay, if you are getting the dual form of F, you need to convert it back to this one, right? Convert it back to A, B or C, D. Okay, this is A or B and C or D is a dual form of A, B or C, D. Okay. So here what you need to do is you need to convert it back to this NOR logic. That means if I am having A or B, yeah, okay, 1 second. So if I am having like this, okay, I am having, yeah. Now if I am having A bar, here what I am getting is A bar dot B bar or C bar dot D bar the whole bar. Okay, so that is A or B and C or D. That is a dual of A, B or C, D. Now you need to convert it back to A, B or C, D. So what is the only provision? Either you have to note it. Okay, that means if A or B and C or D is noted, what you get? You will get A or B the whole bar or C or D the whole bar. So what is it? A or B the whole bar is A bar dot B bar or C bar dot D bar. Okay, so that will come to this one. That will come to A bar dot B bar dot or C bar or D bar. Okay. Now, if I am doing it in a different track like this, so here we get C D A B bar A bar dot B bar C bar dot D bar. Okay. So here what we are getting is A bar dot B bar or C bar dot D bar. Okay. So how to handle with this case? So here we get A or B dot C or D. So you are actually getting the dual. So how to handle with this case? Now go to the third step, that is insert NOT gate wherever necessary. Okay. Now here where NOT gate is necessary. Yeah. If you are having a NOR, suppose I am proceeding a NOR gate. Okay. What is A bar dot B bar? A bar dot B bar is A or B the whole bar. Yeah. A bar dot B bar is A or B the whole bar, and C bar dot D bar is C or D the whole bar. Okay. So here you are having two barred inputs which is going into the NOR gate. Okay. So here we can resolve the circuit like this. You can having a NOR gate. Yeah. A, B. So this is A or B the whole bar. Then this one. This is C, D. This is C or D the whole bar. Okay. Now if these both are fed into a NOR gate, suppose if I am getting the circuit like this, so here what we get? You will get A or B the whole bar or C or D the whole bar, Okay. So what is it? That is A or B bar dot C or D bar. So what is it? What is A or B the whole bar? That is A bar dot B bar the whole bar dot C bar dot D bar the whole bar. So again it will come back to A or B and C or D. Okay. Now here one question. Now see, if I am having A, I need to get what? I need to get F is equal to A and B or C and D. Okay. How that is possible? That is the next question. That means here actually you are getting the dual of, this is the dual. If you are considering these two, these two are getting the dual. If you are getting dual expression while converting, then easy way is from the input itself you note it. That means if I am having A, I am having a NOT gate. B, I am having a NOT gate. So here what will I get? Here you will get A bar or B bar the whole bar. Yeah. Again, this is C, D. So we will get C bar or D bar the whole bar. Okay. What is A bar or B bar the whole bar? That is A bar or B bar is AB bar. A bar or B bar is AB bar. That is AB bar the whole bar. So what do you get? You will get AB. Similarly, this is CD. So if I am taking this into another NOT gate, another NOR gate, here what do I get? Here what I get is AB or CD, the whole bar. Okay. So here you will get AB or CD whole bar. And if you are taking the NOT of that, if I am taking the NOT of that, what will I get? You will get AB or CD. And here we are having two NOT gates. Four NOT gates. You can replace it by again NOT gates. So you can have A, B. Okay. A is again replaced by a NOR gate. B is again replaced by a NOR gate. Yeah. That is again NOT. Yeah. Similarly, C is replaced by a NOT gate, that is using NOR logic of C. D is again replaced by a NOT, and these two are again given to a NOR. Yeah. Again, these two are NOT. Okay. Again, that is NOTed. So this is the basic NOR logic. This I have done with an easy track. This is the basic NOR logic. Okay. So if you are performing the performing the conversion to NAND logic or NOR logic, if you are getting the dual expression, better note the inputs. Okay. You can have noting the inputs of you can note go for noting the inputs. Okay. So that is regarding NOR logic. Okay. Now coming into third question. So that is the first question, right? Coming into second question. Realize the following Boolean expression. Realize the following Boolean expression using AOI logic, NAND logic, and NOR logic. Okay. See here, the intention is you are not going for the minimization of gates. Okay. That means you can do with any number of gates. Okay. So if the question is very much general, without specifying minimization or maximization, you can go with any number of gates. Okay. So I am given the expression f is equal to AB bar or A bar B. Okay. So this is basically an exclusive OR gate, XOR gate. So AB bar or A bar B. So you can have going for AND or invert logic. We are having two inputs, A, B. First case is it is direct, and second case is it is noted. Okay. B, you are having direct, and the second case B is noted. Okay. So first is AB bar. So here you get AND gate. So like it is AB bar. This is if you are getting AND gate, you will get A bar B, and you are ORing it. Okay. So here what we get is AB bar or A bar B. Okay. So this is the basic AOI logic of XOR gate. Now I am going to convert it into NAND logic. Okay. How to convert it into NAND logic? Okay. So the first step is you are making all AND gates to NAND gates, AND gates to NAND gates, and making this OR gates to bubbled OR gates. OR gates to bubbled OR keys. Okay. Here I am not intending to go with the minimum number of keys. Okay. So let me check whether it is possible. So you already have is A is coming in. Yeah. B is noted here and going in. So here what you get, A dot B bar, the whole bar. Okay. Again here A is noted, B is directly coming in. Yeah. So here what you have is A bar NAND, that is A bar dot B, the whole bar. Okay. And I am making it into bubbled OR. Okay. So let us check what is the result. Okay. So what is A dot B whole bar? That is you will get it as A bar or B by De Morgan's law. What is here you will get A or B bar. That is by De Morgan's law. Again here what you are getting, A dot B bar the whole bar or A bar dot B the whole bar. Okay. What is it? That is again in this form, that is A bar or B, A bar or B or A bar or B or A or B bar, A bar or B or A or B bar. Okay. Now if you are looking to this expression whether it is a dual, see if you are, can you check whether it is a dual? See, if you are looking to these two expressions, it seems that it is not the dual. Okay. It is not the dual thing. Okay. This is not the dual. Not dual. Okay. So how will you proceed? If it is not the dual, then what you can have is you can note in between. Okay. If it is not the dual, then you can note in between. So I will go with the same thing. So A is there, B is there. Here we are having A, B bar. Okay. A is there. Here you will get B bar. So this is A bar. Yeah. I make it into NAND. This is B. This is A B bar, the whole bar. This is A bar B, the whole bar. Now I am noting it. Okay. Now I am noting it here. So what will you get? You will get A B bar. Here what do you get? Here you will get again A bar B. I am just noting it. Okay. Now coming into this bubbled OR gate. Now coming into bubbled OR gate. Let us see what happens. So here what do you get? AB bar bar or A bar B bar. Okay. Yeah. So here we get AB bar bar. So we get AB bar is coming in and it is noted. It is noted and going in. So you get AB bar bar or A bar B bar. So if you are simplifying that expression, what do you get? You will get A bar or B or A or B bar. Again the same issue. Okay. That is the same issue what we have felt here. Okay. So if I am having A B bar bar, that is noted means you will get, yeah, okay. Suppose if it is not noted, okay. Suppose this not gate is not there. Let us check what happens. Okay. So that is going in. Similarly, this is also not noted and this is also directly going in. Yeah. Then what is the case? If that is the case, then what we can have is so here you get AB bar bar or A bar B bar bar A bar. Oh, this is AB bar 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 the whole bar. Yeah. Okay. Oh no, whole bar is not there. Yeah, right. Okay. So if this is the case, what do you get? You get it as AB bar or A bar B. Okay, that is your required expression. And what is this? Bubbled OR gate. Bubbled OR gate is basically what? Is basically NAND gate. Bubbled OR gate is basically NAND gate. So now we can replace it like A. You will get B. We can replace like this and give a NAND gate here. So you get A B bar. This is A B bar the whole bar. Now coming to A. A is noted. So what we get is A bar. So this is A bar B the whole bar. Again, if I am NANDing it, this is NANDing it. So what do we get? So here what we get is AB bar the whole bar dot A bar B the whole bar Okay. What is it? That is that is A bar or B dot A or B bar the whole bar. Again, if you are simplifying it, what is it? That is A bar or B the whole bar or A or B bar the whole bar. Again, what is it? That is A or B whole bar is that is A B bar or A bar B according to De Morgan's law. So this is the correct circuit. Okay. So now I have converted that XOR gate into NAND logic only. Okay. That means here you are not getting the exact dual. So if you are not getting the exact dual, you should think in a different track. Okay. That is what I have dealt with here. Okay. Now if I am going with NOR logic. Okay. If I am going with NOR logic of the same case, that is F is equal to AB bar or A bar B. I am going to explain the NOR logic. So first of all, let me draw the AOI logic. AOI logic. So A is there. Similarly, here what we are having is A bar. Okay. B is there. So here what I am having is AB bar. Then if I am having B here, what I have is A bar B. This is AB bar. Yeah, I am ORing it. Yeah, so we'll get F. Okay. So to develop the NAND logic, what is the first step? Make AND as bubbled AND, AND to bubbled AND, and make OR as NOR gates. Okay. So A is coming in. So that is going to bubble. B is also coming in, but B is noted and coming in. That is also coming in the bubble. Yeah. Here again A is coming in, and that is noted and again noted. B is coming in, noted. Yeah. So here what we get? Here what you get is a bar dot, this b bar again b, a bar dot b the whole bar. You will get a bar dot b the whole bar there. This is again a dot b and whole bar is not there, constant. So here what we get is a bar dot b. Here we get is a bar dot b. Here what we get is here we get a bar a. So it is a dot b bar. We get a dot b bar. Okay. Now if I am making this into NOR gate, so here what we get? Here what we get is a bar b or a b bar the whole bar. Okay, you will get a bar or b or a b bar the whole bar. Okay, what is it? That becomes a bar b bar dot a b bar the whole bar. Okay, so what is again? It becomes what? That is we get a or b bar and a bar or b. Yeah. Now if you are checking these two, that is a dual. Okay. If it is a dual, what is the step what we can do? We can take the note of the inputs. Okay. If you are getting the dual things, you can get the you can take the note of the inputs. Okay. So if I am drawing it again, so this NOR logic, not NAND logic. That is I am mistaken here. Going into NOR logic. Okay. So again NOR logic. Okay. Again NOR logic. So here what we can have is a is there. A is given in as not. Yeah. B is noted and given in. Okay. So b is noted, b is noted, and it is again noted, and it is again noted. Yeah, b is noted and it is again noted. And what is bubbled NAND gate? Bubbled NAND gate is basically NOR gate. Okay. So here what you are getting, is a bar or b NOR gate. A bar or b whole bar. That is a b bar. That is equal to a b bar. A dot b bar. Yeah. Again, b first note is coming out. Yeah. Then from a after note it is coming out. And it is again noted. B is coming in with a note. Yeah, that is again noted, and this is basically what? So we will get NOR gate, and that too is given again into a NOR gate. Okay. So what is this? This is a or b bar the whole bar. What is it? That is a bar b. Now if I am again NORing it, what do you get? F is equal to, here I am getting f. F is equal to a b bar or a bar b the whole bar. Okay. What is it? That is a b bar dot a bar b whole bar. What is it? Again what we are having is a or a bar or b and a or b bar. Okay. So here again you are getting the dual form. If you are getting the dual form, what you have to do? You have to note it. Yeah. So here you are getting f bar. Okay. So what you are getting is f bar. Okay. So this is f bar and you have to note it. That is all. Okay. Now if you are going into the circuit directly, if you are drawing the entire circuit using no logic only, this expression I am dealing with only with the circuits only, and I am not going with the minimization or maximization part. Okay, so A is not. Okay, so we get A bar. Then B is directly going in. B in this case is directly going in. Okay, so this is target. So this is A bar or B the whole bar. A bar or B the whole bar is what? That is A B bar. Again, here A is directly coming in. A is directly coming in, NOR gate. B is noted and given in. So here you are getting B bar. This is A. This is B. So here you will get A or B bar the whole bar. What is it? A or B bar the whole bar. That is A bar B according to De Morgan's law. Okay. Now, if I am applying a NOR gate here what do you get? A B bar or A bar B the whole bar. Again you have to note it. Okay. So here what do you get? A B bar or A bar B. Yeah. Okay. So this entire circuit is using only NOR gate. Okay. So here how many NOR gates are there? 1, 2, 3, 4, 5 and 6 NOR gates are there. Okay. So I think you have got the logic how to convert a given gate or given expression using AOI logic, then no logic and NAND logic. Okay. Now coming into next question, we will deal the next question in the next lecture. Okay. So please go through this lecture in a good way. So in the first question, what you have dealt is AB or CD. First I have drawn the AOI logic and given the steps to convert it into NAND logic. Okay. No logic also doing the same, but here what is the problem is if you are getting the dual. If you are getting the dual, you have to note the inputs. If you are getting the dual, you have to note the inputs and not the output. Okay. If you are directly drawing it NOR, or NAND, if you are getting the dual as output, you have to note the inputs as well as note the output. Okay, and that noting also too should be done by using this NOR logic and NAND logic. Okay, so that is how you are converting these logic gates. Okay, a basic AOI logic into NOR logic as well as NAND logic. Okay. So with that I am ending with this lecture. In the next lecture we will see how to minimize or how to read the expression and how to realize this NAND gate and NOR gate using how to realize a circuit using this NAND gates and NOR gates only with minimum number of NAND gates and minimum number of NOR gates. So hoping you have understood this lecture and hoping you to be with us on lecture number 36. Thank you.